Hello everyone and welcome back. My name is Mr. Cobalt, and in this short video I'm going to be going over activity decay series. Okay, so let's get into this. As I said in a previous video, atoms with an atomic number greater than 83 do not have any stable isotopes. They're all radioactive. And so in this case, they're all going to decay in either one or more steps, and this is primarily going to be through alpha and beta decay with some gamma radiation emitted as well. So remember, gamma rays are emitted in one way through the rearrangement of the nucleons after you have lost some of them through, say, for example, alpha decay. You're emitting an alpha particle, a helium atom, where you're losing two neutrons and two protons. And so that happens, the nucleus now has to kind of restabilize. And in order to restabilize, it has to kind of rearrange and move the other nucleons that are there in order to reach a lower energy level stability. And so in order to do that, in that process, gamma rays are emitted. But this video is more focused on the other decays, the alpha and beta decays, and the steps that an element will go through. And so, in a lot of these different larger unstable nuclei that are radioactive, they're going to undergo radioactive decay through a series of steps. So here is an example where we have uranium 238. So uranium 238 is going to undergo radioactive decay through a number of steps, lots of different steps. And here I'm showing you the first few steps. So what's going to happen is uranium 238 is going to undergo first an alpha decay. And so it's going to lose two protons and two neutrons. So when it loses the two protons, it's going to go down to 90. And then it's going to lose two neutrons as well. So it's going to lose four nucleons together. So that's going to drop from 238 to 234. And that's going to be thorium. So number 90 on the periodic table is thorium. And here's our alpha particle. So here's the nuclear equation for the decay of uranium 238 to thorium 234, losing an alpha particle. Well, this thorium 234 is itself radioactive and unstable. So the thorium will also undergo radioactive decay. So we take the next step, we take the thorium here, and we write the next step here. So the thorium 234 is going to undergo a beta decay. So it's going to lose an electron from the nucleus. So when it loses the electron, that means that a neutron is going to become a proton. So it's going to increase the atomic number. So 90 becomes 91. But the mass number stays the same because the protons and neutrons have pretty much the same mass. So 234 stays 234. So here we have the radioactive decay of thorium 234 going into protactinium 234 here. And so now we have the daughter isotope is now protactinium 234, but the protactinium 234 is also reactive. So that's going to undergo another beta decay. So we write that here. So here we have protactinium 234 undergoing a beta decay, so it loses a beta particle. And then again, the atomic number 91 goes up by 1 to 92, and we're back to uranium. But notice that we're at a lower mass uranium. It's a smaller uranium. So we started here with 238. Now we're at uranium 234 because it lost a beta particle. And this is still going to go on. So this is still unstable. It's going to undergo the next step in the decay series, and then the next step, and the next step, until it ends at lead 206. So lead 206 is stable, and it's not going to undergo the decay. So I could show you the decay series here. So, ladies and gentlemen, this is what the decay series looks like, and you can look this up on the internet or something like this. There's a lot of different ones out there and way they show this, but I like this because it's clear. You'll notice here at the top we have uranium 238, and that's going to undergo your alpha decay. And so let me go back and start by explaining the graph here. So you saw this in my earlier video. So down here, the x-axis, we have the atomic number Z, so the number of protons on the bottom. And then on this side over here, we have the number of neutrons. So now on the y-axis, it could be the number of neutrons, but I've also seen this with the mass number as well, which is the number of protons and the number of neutrons together. So either way works. You can show the decay series by plotting either the atomic number to the number of neutrons or the atomic number to the mass number. It works the same. So this one is showing the number of protons on the x-axis and the number of neutrons on the y-axis. So with that out of the way, we can see that here we have alpha decay and beta decay. Alpha decay is going to make the particle go down in the number of neutrons and the number of protons. But beta decay is going to make it go down in the number of neutrons, but increase in the number of protons. So you'll see that with the arrows here, alpha decay is going down towards the left, but the beta decay is going down towards the right. So you could see that uranium 238 up here, uranium 238 undergoes an alpha decay and goes down to thorium 234. So it goes down in neutrons and protons. But then thorium 234 undergoes a beta decay to protactinium 234 here. Right, my finger isn't working. And then it undergoes another beta decay and goes down to uranium 234. So it's growing in the atomic number from 90, which is thorium, to 91, which is protactinium, to 92, which is uranium. So, and then we have a series here of alpha decay. So you could see here alpha decay, alpha decay, alpha decay, and so on. So you could see how the uranium 238 goes through this long series of beta and alpha decays. And also there are gamma radiations going on during this process as well, but we're ignoring those. And you could see that finally down here at lead 206, that's where it stops. And so that's where the nucleus is finally stable enough to not undergo a decay, a radioactive decay. And so that happens with a lot of these large nuclei. So uranium 238 isn't the only one. There's other nuclei that undergo a similar decay series. And so that's it for this video. I hope this was helpful. I hope you learned something from it. If you enjoyed this video, then please like the video, hit that like button, smash that like button. Don't forget to subscribe to my channel. So hit that notification bell right up there, or maybe it's down here. Maybe they moved it on me. I don't know. I'll have to double check. So if you hit that notification bell, make sure you hit all, and then that way you'll be notified by all the videos I put out. And also put a comment down in the comment section and below. Let me know what you think. Let me know if you have any questions. I'd love to hear from you. Thanks for joining me, and have a great day. And that's my cue because the lights went out. Thanks for joining me.